Write the following expression as the logarithm of a single quantity. Well, you notice on these logarithms here there is no base given. And because there is no base given, it's assumed to be 10 as a base, which is known as the common logarithm. There are two different formulas that are going to be used, and these apply to the log of any base, but I'll go ahead and just write log and ignore the base here. They apply to base 10 or any other base. If you take the log of one quantity times another quantity, that is going to be the logarithm of the first plus the logarithm of the second. There's a second one that we're going to apply here, which is the logarithm of one thing divided by another thing, and that turns out to be the logarithm of the first minus the logarithm of the second. So those are the two formulas that are going to be used as we're trying to calculate the value of the log of x plus the log of xy squared minus the log of z. Start with this, the first two terms here, log of x plus the log of xy squared. That looks like this right here, so we can write that as the log of the product of those two. So you can write that as the log of x multiplied by xy squared. And then we put on the last term, which is minus the log of z. Finally, we have the log of one thing minus the log of another thing, and that looks like this right here. So that can be combined as the quotient of the two. And so this will be the log, and in the numerator we will put this quantity, and in the denominator we will put this quantity. However, instead of writing this as x times y squared, I'll write that as x squared y squared, and then down in the denominator goes z. So we have done what was asked for, which is writing the expression as the logarithm of a single quantity. Here is that single quantity.